There we are. Thank you, Tom. It's really great to be back after having retired a few years ago from the CARA board, and to sort of remind everyone what you probably already know about how all this really began and why we are all here today to talk about 20 years of really great science. This was 1983-84. At that time, this was the largest, for 35 years, had been the largest, most productive telescope in the world. And of course, at that time, there was already indications, and the three people who got the Kavli Prize were all part of that there finally was a new era of technology, and that in some time in the not too distant future at that time, 83, 84, there would be larger telescopes using either the honeycomb approach, that spinning, which Roger Angell had, or the thin meniscus, which Wilson developed, or in the case of Keck, it has turned out, the segmented mirror, which Jerry Nelson developed. So there's Jerry. He's already been introduced. He started in 1977, as I recall. I was not yet involved at all at that time. And of course, there were several key innovations. One was, how do you polish an aspherical segment when you like to polish spheres? And so what Jerry and his team developed was the idea of just bonding a lot of levers to the edge of the disc. The disc was only about that thick. You bend the disc in such a way that you can polish it into a sphere. Then you release the force, and it warps into exactly the shape you want. All sounds easy, but most people thought it was crazy that you could do this. But that's what Jerry and his team developed. And another thing was, how do you support this very thin piece of glass on 36 slender rods of stainless steel? So they developed what's often called the Wiffle tree, 3 separate assemblies, all pivoted in such a way that as you push on the back of the mirror to position it, it does not bend the mirror. And of course, there had to be sensor systems to be able to locate the mirrors as well. One of the key steps in this process, of course, is you start with a disc and you want a hex. And so you have to cut the ears off. And that was the most difficult part in the end, the most difficult part. The problem was not really solved when we started building the Keck telescope. It was only solved when ion beam polishing was developed by Kodak, and that allowed us then to make the final adjustment for the effect of cutting off the 6 ears and releasing internal stresses. So this is 1984. Obviously, not only a new kind of mirror, but a new kind of telescope structure was part of what Jerry and his team put together. And in fact, the University of California had gotten a promise of a $36 million grant to build the 10-meter telescope. The Hoffman Trust was involved. That was clearly not enough money, $36 million. So you see, invited Caltech, because at that time we were looking at these 3 different options, trying to decide where the opportunities were and how Caltech could become involved. And UC invited Caltech to join as a 25% partner for $25 million. And we went to our board, and the board of trustees agreed that the president, Murph Goldberg, could go try to find the $25 million to become a partner in the Hoffman telescope. Turned out at that time, Howard Keck, whose picture is already seen, was on the Keck board. The Keck family had been involved with Caltech for a very long time. And he heard the presentation we made, but said that he was not interested in funding a Hoffman telescope. He was interested, though, in funding 70%, 80% of a Keck telescope named after his father, which had set up the foundation. And we were very fortunate in the sense that the Keck Foundation at that time had just sold its stock in Superior Oil and, in fact, was able to make such a large grant. It hadn't already committed years before its funding wedge, and that turned out to be a very important part of timing. Timing has been very important in this whole process. There's Howard Keck holding an O stick from one of the dedications of Keck. This would be the groundbreaking for Keck 2. There's Jerry Smith, a somewhat more recent picture than Tom had. We needed a project manager once the Keck Foundation said they were interested. next job was to find a project manager, and Jerry Smith was an obvious person. He had finished in the 70s the NASA Infrared Telescope facility, which was built to support the Voyager encounters with Jupiter. And that was 1977, 78 when he was working on that telescope, 3-meter telescope. And then he then worked, was a project manager on the infrared astronomy satellite, which was observatory, which was launched in 1983. Tom Seufer, in fact, spent a good deal of his career working with data from IRAS. So Jerry was the ideal project manager, having built both a ground-based telescope and a space-based telescope. And so that meant that we could, in fact, form a partnership, an equal partnership, it turned out, between Caltech and UC. We had designed the facility so there could be 2 telescopes, so that should the Hoffman telescope be built, it could be built right next to the Keck telescope. At the time this was announced in January of 1985, it was the largest gift ever made for a scientific instrument. It was $75 million. How much was it? I don't remember now, but it's 80% of the cost. Here was the site. That's the IRTF up here, and CFHT over on another Pu'u, and a road was created between these two. So here's the site leveled. There are the shovels ready for the groundbreaking in September of 1985. There's Howard Keck right there. There's Murph Goldberger, David Gardner, Bill Frazier, who was the chair of the CARA board at that time, and Albert Simone, who was the president of University of Hawaii, and the kahuna that blessed the whole event. Howard was not somebody who micromanaged how we ran things. His idea was you create a good team, you give them the resources, and you get out of the way. But that didn't mean he was uninterested in how things were progressing. Here he is. Obviously, the dome was almost not quite finished at that point, and he flew with us to ITEC, which was polishing the mirrors when we had some challenges polishing the first mirror. Jerry developed the technology, but transferring it turned out to be very hard. But so Howard was very supportive in helping us make that happen. Here is the Keck 1 telescope as it came together, and we dedicated. We had the first light with the telescope in December of 1990, and we had first light in November 1990, and in December 1990, we announced that in fact the Keck Foundation was interested in funding a second Keck telescope, Keck 2. So that all happened in the December 1990 time period. The first light we had, by the way, was with 9 segments, not with 200. 9 segments made it as large as Palomar, so we could claim that we had now one of the largest telescopes in the world with just 9 segments. That was enough to, in fact, provide the opportunity for the Keck Foundation to fund the second telescope. The challenge then was that Caltech had to raise the rest of the money for both Keck 1 and Keck 2 because the foundation didn't fully fund it. That was my job, and fortunately, timing again worked out very well. At that point, NASA had been looking at a program called TOPS towards other planetary systems, was interested in interferometry and access to a large aperture telescope, and agreed to join as a 1/6 partner in both Keck 1 and Keck 2. So the timing again was just right. I can't imagine today going to NASA and expecting them to be a 1/6 partner of a ground-based telescope. But at that time, it worked for them. It's been great for planetary astronomy at NASA, and obviously has given us two of the best telescopes in the world. So there it is with the 36 segments. We had a groundbreaking for Keck 2, and a dedication of Keck 1 in November of 1991. So that was we had all 36 mirrors in at that time, and it obviously took another year and a half to get to the point to what we're celebrating today, the first scientific observation which occurred in 1993. So there's Keck 1. There's Howard Keck and Tom Everhart, who was the president of Caltech. At the dedication of Keck 1, this was the November 1991 period, and Howard Keck, and with a small model that he was given in recognition of the tremendous support that has made this all possible. Here's the groundbreaking for Keck 2. We did it all at the same time. And this time with O-sticks. You can see improved cultural sensitivity by that time about using the mountaintop for astronomical purposes. And there they are, the two Keck telescopes as they were. They were dedicated in April of 1996. Unfortunately, Howard Keck could not be there. His health was no longer made it possible for him to fly. In fact, he died later that year. But we did arrange to video by satellite. There was still no internet at that time to speak of. Video by satellite, the dedication event of Keck 2. There was one last thing, though, one last interesting timing. And Claire Max was an important part of this. That is, in about the time we were negotiating with the Keck Foundation with regard to Keck 2, the whole adaptive optics technology was declassified. And that made it possible for us to develop a proposal, a plan, I should say, really, and so that I had that plan, if you like, ready. And as it turned out, we were underrunning the cost to build Keck 2. We really had learned a lot building Keck 1, and the Keck Foundation agreed to allow us to use some of the underrun money for the first adaptive optics system on Keck 2. So again, timing was really critical. It turned out that things all came together just right, and the first laser guide star light was in 2001. And of course, as you know, it's really, again, been leading the way. So I would like to end with a video that was made in 1991. It's three pieces. You'll see first the construction of the dome, then you'll see a time-lapse image, and then finally you'll see the installation of the telescope.
What follows is the story of the construction of the W.M. Keck Observatory and Telescope, told in pictures, sound, and music, a compilation of elements representing over 6 years of photography.